Hello all, welcome back to our course on digital accessibility, and today we will talk about mobile and mobile apps and how they can be leveraged in making or innovating new accessibility devices, accessibility innovation, and how it is a very powerful accessibility tool by itself, just by its nature of multimodality and just by its nature of being largely available at a consumer level. So first is definitely, we've been iterating throughout this course that why accessibility matters, and accessibility is about inclusion and not just compliance. It's not just about following the law or not following some compliance and guidelines of WCAG. It is beyond that, because we are enabling access to more than 1 billion people living with disabilities according to WHO. Right? And disabilities can be of various kinds: permanent, temporary, situational. And mobile devices, by its very nature of being now readily available at different price points, considering it has different kinds of sensors, now it is also has internet enabled and all of those facilities, and plus it's a small handheld lightweight device. By its very nature, it plays a very key role, not just in everyday interaction but also in everyday access. So why we should, as innovators, as engineers, as designers, think about mobile accessibility to begin with? One is, as I mentioned, that they are personal devices, they are portable devices, they are available with you at all times. Most of the individuals have separate devices, each one to their own, where customization, personalization is also possible. So that gives us a very strong advantage in any design, in any new technology, new media that we would like to build. Because we are constantly talking about customization and personalization and how technologies which are adaptable to varying needs of varying individuals can be of more benefit. Then the second most important aspect being that it is a very low cost device compared to dedicated assistive devices. So when we say dedicated assistive devices, in some of the previous sessions we have spoken about something like refreshable braille display, something like note takers. They are some devices which are specific devices, and the scale doesn't justify bringing down the cost a lot. Plus they may be high technology investment, high R&D devices also. That also carries in the price point. So but mobile devices are largely very multifaceted, plus they are available at different price points, right at the nominal starting point of 5K, 3K rupees in India. And then of course you can also buy a used or a refurbished model which also has a higher processing capability at a much lower cost as well. And today we are all aware that mobile phones is used across most verticals like education, healthcare, finance, communication, etc. And all of these industries are leveraging individual information, individual access, and that can be a very important entry point if we are thinking of innovating for the special use cases as well. So smartphones can replace or augment assistive hardware, primarily because it can support multiple accessibility needs. It has softwares which can be continuously improved. Customization is possible and personalized access is possible using mobile technologies. There are also various built-in accessibility features in mobile phones, particularly at the OS level itself. So I'm sure like we have spoken about TalkBack, we have spoken about assistive touch in the iOS, we have spoken about voiceover, and there are other accessibility features like dark background, high contrast ratio, and all of those things, or multimodal feedback mechanisms, right? So if a call comes, you can have flashing lights as well as vibration, vibrotactile feedback, as well as a sound feedback. So depending on your need, you can activate or deactivate the different feedback systems. Plus, it is also contains several sensors which can garner or gather information about the environment, including your camera, your microphone, your GPS, your Bluetooth, and all the other balancing sensors and distance sensors and all of LiDAR sensors, which we can leverage in order to know more about the surrounding which our user is interacting with, and use that information into processing and delivering an appropriate feedback. So models such as obstacle detection and all of that is possible to implement on a mobile phone. So a person, for example, who is walking and navigating a space in where he or she is a person with visual impairment or blindness, he or she wants to navigate through that space, but there may be certain obstacles. So if there are several such apps available which are leveraging your camera input, they are processing it in real time and giving the user the feedback that okay, so and so is there in front of you. Right? You may not always want to touch and then identify what is there in front of you, right? So it may be an animal, it may be a dirty dump truck, it may be a person who doesn't want to be touched, it may be a stranger, right? So it's not always touching and then identifying. So then in those situations, an obstacle detection or a object identification algorithm which can be implemented using the camera input of your mobile phone can be a very useful tool as an assistive technology tool. Again, simply implemented on your mobile phone. So we are leveraging the hardware and just augmenting the existing sensors with a software layer so that they can enable access to the environment or any other information. So for example, in an upcoming product demo, we will also showcase one such smartphone based assistive technology system where we are again leveraging the use of camera input, and we are trying to read the NCERT, CBSE textbooks where the user is actually just moving their hand on the page. It's a printed textbook, there is no tactile feedback. The tactile feedback is just for the page flipping and the corners, etc., so that they get some feel of reading a book. But then based on the gesture recognition through computer vision models, the application is able to then narrate whatever is written on the paragraph where you are pointing. And similarly, we are able to annotate different variety of geographical information on one geography map. So for example, there may be a crops map. I'm sure you all might have studied in school. There is a crops of India maps, there is industries, there is a political map, there is a physical map. all of them are different maps. So, but what if I tell you that there can be an application where there is one tactile outline of the India map, and a person or a student who is blind can just explore that map and select which information they want to hear, and based on the location of their finger, that application is able to tell them, okay, this is where cotton is grown, this is where highest rainfall happens, this is where Maharashtra is, etc., etc. So now let us talk about these are few examples where we can think about leveraging the hardware and augmenting it with some another layer of developed software in order to develop an innovative assistive technology solution, and you will see a demo in a upcoming session. Now let us talk about some of the accessibility features which are inbuilt on the mobile phone and which are very helpful for users in their day-to-day needs. So, one is definitely your screen readers for persons who are blind and low vision. So, which is again your talkback, etc. So, you can just explore those features on your phone right now. You can go in the settings and of your phone, and then there is an accessibility setting. You can turn on the talkback and it will start telling you each word and the navigation keywords in an audio format. Then there is magnification and display adjustment. So, the fonts can get bigger and you can change that setting on your phone, which is your master setting. So, any app that you open will also follow that master setting of your phone. Then there can be voice or speech input. Now, we all have, iOS users have your Siri, and Android users have your OK Google interfaces, where you can actually, you don't need to even navigate to a certain app. So, for example, I want to schedule a meeting for Friday 4 p.m. I can just say, hey Siri, please schedule a meeting with so and so on Friday at 5 p.m. So and so location, and Siri will be able to do that in your calendar and set a reminder for the same. Right? You don't even need to navigate, spend the cognitive energy, spend the time to do it, and that itself is an accessibility feature. Then there can be switching between alternative input access. So, voice, of course, voice and speech is one. Thinking about linguistic inclusion. So, your keyboard also has Hindi or other Indian languages. There are, of course, global languages enabled, so Spanish, French, etc. And you can choose in what way you want to interact with the system, the mobile phone. So, I think that itself these are some of the inbuilt features. Maybe you can discuss on the forum about what other features you might have recognized or identified on your mobile phone, which we might have missed mentioning here. So, now let us talk about each one of them in a little bit more detail. So, what are screen readers on a mobile? So, they convert on-screen content into speech or braille. They support gesture-based navigation. So, if you want to go to the next item, next interactive item, so there are 4 buttons on your interface. I am currently in heading 1, button 1, whatever, and I want to go to heading 1, button 2. So, I can just keep swiping right. So, the keyboard interaction for a screen reader is tab, but on a phone it is swipe, so it is gesture based. And but in order to make sure that your application is well aligned with this mobile screen reader, you have to evaluate with these screen readers at the development level itself. So, we will talk about this in much detail in the upcoming week, where we will talk about evaluation methodology and evaluation pipelines. So that the point is that we need to have well structured UI elements. So of course examples are that Android phones have talkback, iOS phones have voiceover. Both can be just simply enabled by going to settings and just turning them on through accessibility dialog box. Magnification and visual adjustment. So what happens in this case is that you are able to zoom onto the screen. There can be gestures which are magnification gestures, where you are kind of pulling your two fingers apart and it is able to zoom. You can adjust font sizes or other display scale. You can change the color contrast, you can do color inversion also. So for people with low vision or light perception, they can use color inverted modes. So these kind of features can support users not just with low vision but also with users who are elderly. So many a times they would require larger touch targets, for example. So magnification can help us in making the touch targets bigger as well. The font sizes, if they are too small, the screen is too cluttered in terms of reading. And sometimes elderly users may be facing hypermetropia, which is in layman language called nearsightedness. There you are unable to read when something is at a reading level, right? So if it's something very close, if it is too small, you're not able to read it properly. So then those font adjustments can be utilized and fonts can be made bigger easily. Then we spoke about the voice-based interaction. So that enables hands-free interaction. So it is a boon for people with motor impairments. We will talk about this aspect in the next session as well. And it is very useful for people who may have motor impairment or motor fatigue issues, or people with cerebral palsy where the fine motor skills or gross motor skills are largely affected by their impairment. And it can include your voice typing, so dictation, you don't need to type a message, you can just voice, press the mic button and ask it to write the message or whatever you want to say. Hi, let us meet at so and so at so and so. Or voice commands, as I mentioned earlier. Hey Siri, book meeting slot for me for Friday, something like that. Or it reduces reliance on precision touch input, right? Which is also, again, people who are elderly may face problems with precise touch targets, precise touch interaction requirements, and then people with the cerebral palsy or other motor impairments may have similar issues which can be easily overcome by using voice-based interaction, which a mobile phone, even the ones which are very available at a very low cost, can afford all of these features now. Then touch interaction challenges. So small touch targets create barriers, right? So complex gestures are hard to remember sometimes. And motor tremors may affect accuracy. So your application design should think about at the time of design itself about tolerating error, about all of these variability of interaction. And if you again go back to your basics and look at the WCAG guidelines, there is a lot about touch targets, etc. But I think in this because largely WCAG is for web-based interfaces, the new version WCAG 3.0 talks a little bit more about mobile interfaces, and a portrait based smaller screen interface largely. So I think some of the aspects can be picked up from there, but one should not just rely on compliance. One should also keep evaluating with users at a continuous basis, if particularly you are developing new solutions. So mobile accessibility is very useful, particularly in education, because accessible e-books and learning apps are available. Audio supported learning content is available. Support for captions and transcripts are available. It allows for independent learning. So then there are multiple examples, I'm sure you also might have used, of accessible learning apps. So for example, screen reader friendly navigation, they're looking at that. Audio feedback for interaction, so adjustable text and layout, they support diverse learning needs. So all of these are some of the examples of learning apps which have all of these features ingrained in their interaction. Another important vertical where a mobile phone can be very useful in terms of accessibility is your navigation and mobility. So since this is a portable mobile device, you can carry it with you at all times. And largely, I'm sure all of us have seen people, when we are driving, we are putting it for map access, or when we are riding a bike, we are putting it for map access. The same can be true for people with diverse needs, and it is a very reliable source for GPS based navigation assistance. Already it's GPS based navigation is in its very robust stage. All of us have used Google Maps or Apple Maps, I'm sure, to navigate their way through a new city, or if they are going to a new place in the same city. So I think that is there. Then public transport and wayfinding apps are also there, particularly say for bigger cities like Delhi. There is like a metro rail network which is quite complex, so they have their own apps. So okay, if you are here, which station you can board, which is the nearest station, and if you want to go to say a Red Fort, which station do you deboard, how many times do you change the train, and all of that. Then it also kind of tells you audio directions, gives you vibration cues, so multimodal feedback. Again and again we are saying that a mobile device is capable of doing that. So the app design should leverage all of these feedback mechanisms. And it is very critical for independent mobility, because if somebody has a sensory deprivation, one kind of sensory deprivation, somebody is hard of hearing, they can rely on the visual or the vibrotactile feedback. If somebody has low vision or visual impairment, they can rely on the audio and vibrotactile feedback. Same is the case with if you are distracted, for example, you are driving, you are distracted, your attention to both the visual or the audio stimulus is not there, then your third feedback system, which is your vibration, can pull your attention back to the navigation system maybe. So it is very critical. Other than that, communication and expression in terms of speech to text for users with hearing loss, text to speech for reading support. Then there are AAC apps for expressive communication. This is largely for people with autism, etc., who are not able to kind of remember words for everything. They can kind of communicate through such applications, or people with cerebral palsy, or people who have speech impediment. They can use such apps. It also supports social inclusion. definitely, because these are not specialized products. Everybody today has a smartphone, and if we are able to leverage that hardware, it's not something weird looking, it is not something only I am using. If there is a specialized solution, we may think that yes, it is a good innovation, it is going to help the person who is in need. But if you we have discussed about this, that even a specialized solution is actually not inculcating equality. It is still, it is enabling access probably, but it is still inequality, right? So then, because it's not the same as what everyone is using, I am getting a special treatment, right? So then that is also something people with impairments are not, they're very careful about that. So they're also looking for social inclusion, that I am part of the society, I want to fit in, I am same as everybody, I don't need any special treatment, right? So that individual positive mindset is also enabled through something which is an inclusive product rather than a specialized product. Then there can be some other multiple everyday accessibility scenarios where a application, a mobile application can be of much use. One is of course your mobile banking and payments, your healthcare access and telemedicine, your shopping, e-governance, social media participation. It's so I want to buy something, I want to pay, just by scanning, a QR code. I don't need to, go through the long, tedious route of entering somebody's phone number or account detail to transfer money. It's a quick way of, giving somebody money. And or if I want to buy something from an e-commerce website, I mean, all of that is enabled through mobile phones. Now let us talk about, so of course when we are designing for mobile when we are designing applications for mobile, there may be some inclusive design principles which have to be kept in mind. So we have to design for diversity and not the average user. We have discussed it in detail in one of the earlier sessions. You can maybe go back to that also. We can provide multiple ways to interact. So multimodal interaction is the key. You have to provide options so that it is inclusive to a larger number of audience. Avoid reliance on a single modality. This is something very important. And allow user control and customization. So personalization of the settings, the personalization of display, your voice, which modality I prefer, which one I want to interact with, what screen contrast I would prefer, what font size I would prefer. All of those should be part of your design. And of course, referring to your WCAG guidelines can be a good starting point. Then our design should also be responsive and adaptive. So now with AI and AI based solutions, it has become need of the hour that our designs are adaptive. It contains dynamic content. It can kind of iterate itself based on the personalized need of the user. So, and other than that, there can be some basic robustness related aspects as well when we talk about responsiveness. So, for example, supporting different screen sizes or different orientations. It is able to respect the OS level accessibility settings. So, when you are designing your application, always remember that your system accessibility setting should take priority. It should not override your visual design or something. So if the user has enabled certain font size on their mobile phones, but your app doesn't respect the OS level accessibility settings, then your app will have smaller font and they will not understand why it is happening, and there is a good chance that they may not use it. So if in order to enable the fact that you are able to retain those customers as well, make sure that your app is able to respect the system accessibility settings. So then other than that, semantic meaning of the content is also important, particularly from a screen reader sequence perspective, and we have spoken about this in one of another session where we have spoken about parallel architecture and all of that. Essential for inclusive mobile experiences. So yeah, so it is, all of these aspects are quite essential to create inclusive mobile experience. So some of the commonly occurring accessibility barriers may be your low color contrast, that's the most common, then your missing labels, particularly in form fields, or your all text is missing in buttons, etc., or your gesture only recognition, gesture only interaction is there, but if I want to do through the GUI, I am not able to do it. So poor focus management. So if you have too many visual elements on the application, including ads, etc., it may be very difficult to focus on what to do, where is the call to action. So why it is important to understand the barriers? So because small issues like these can fully block access, and while they seem to be very obvious barriers, unfortunately most of the applications are failing in compliance just because of these very bare minimum barriers. And many times at a coding level, the developers are not able to understand the correct use of labels, context dependent use of labels, or they are not able to understand how to leverage ARIA labels, for example, in a web interface. So it is very important to think about all of that. And barriers compound for disabled users. So all of these may be one kind of a barrier, like for example, for a low vision user, the color contrast may be an issue. But I mean, for somebody who can see, it may be a hurdle, but they might be still able to interact with it. But for somebody who is low vision, then it is almost impossible for them to interact with your system. So such kind of accessibility failures, they reduce independence, and good design should focus on removing all of these friction. So of course, all of these interactive elements amounts to a major chunk of the accessibility barriers and accessibility compliance related aspects. But another very important aspect which we have to keep in mind, particularly when we are developing for mobile users, is specifically in rural and remote areas, there may be low resources, low limited internet connectivity, or older or low end low processing power devices are used, or many a times people don't have their own individual mobile phones, and maybe one mobile phone is being shared among 4 family members. So it is important that we should not rely too much on cloud based interaction, so that every interaction is fetching some data from the cloud. That means that there's a lot of dependency on internet, right? So one should think about leveraging offline solutions and leveraging lightweight solutions, so that even in limited connectivity or low processing power mobile phones, your applications are able to run smoothly. Then, of course, we have spoken at length about WCAG principles and how they can be divided under the POUR: perceivable, operable, understandable, and robust. The same principles, although these principles were initially built for the web interfaces, but they can definitely be extended to, at least from a design principle perspective, very well applies to your mobile application design as well. We have spoken in depth about WCAG principles, each category in one of the earlier sessions. So you can go back to that session and go kind of revise it, because this is one important aspect which is coming up again and again. So WCAG is something by the end of the course you should be thorough with. So other than that, what we can think about is we can think about content descriptions for UI elements. We should think about logical focus order, particularly for the screen reader sequences. Then the minimum touch sizes should be either scalable as per the requirement, or to be on the safer side, it can, if it allows, your visual design allows, and if you can make it slightly bigger as compared to the required minimum sizes, why not? Voice over integration or talkback integration, which is your screen reader mobile of the mobile phone, you have to keep testing with those tools in order to understand about the logical focus, about alt text, etc. Whether the alt text is making sense or not, are multiple labels being read at once. So all of those things matter. And dynamic type for scalable text, accessible controls and settings, and consistent focus behavior. So one should, so what is the meaning of consistent focus behavior? That, for example, there is a workflow where there is few questions on one page, and then you have to go to next page, and also there is a back button. So if on every page the position of the next button keeps changing, it will be very difficult for users to interact with that interface. So that consistency is required, or the color of the button keeps changing, or the labeling is not there in some of the pages, then it becomes very difficult if it's a long form content particularly. So now beyond all of this, there is definitely ethical aspects related to mobile accessibility as well. One is, of course, your compliance related laws, and of course, other than that, now accessibility has been identified by the government of India as a human right, and respecting user dignity and autonomy should be the primary goal of compliance. And particularly targeted exclusion through design, it can be punishable as well by law, and design choices have to think about social impact in the long run. So some of the future directions which are possible in mobile accessibility is, of course, your AI enabled personalization, context aware assistance is possible, multimodal interaction we are anyways doing in your mobile accessibility. All of these aspects can allow for greater independence for users of varying needs. So at this stage, if you are a designer or a developer or a student who is just learning about accessibility, just learn about accessibility, think about accessibility from early stages of design or development itself. Plugging it in at a later stage can be very difficult, and we have spoken about this point multiple times, that when you are developing any particular product, it can be an application or a website, any digital product, you have to keep testing it with a variety of users, and test with assistive technologies like screen readers, test on various platforms or play various kinds of devices to understand low resource settings as well. Learn from real users, and always remember that accessibility is an ongoing process, and even if your even if your application is kind of passing the accessibility guidelines or criteria, success criteria, there may be some aspects of interaction which are getting affected, which can be improved, which is coming from user feedback. Please don't hesitate to include that as well. And as the technology is developing and our phones are getting smarter by the day as well as cheaper by the day, I'm sure it will become even more robust and even more easier to leverage this technology in our day-to-day requirements, more so with AI-powered personalization and context-aware solutions. So that is it. So some of the key takeaways from this session can be that mobile devices can democratize accessibility because it is largely now available with everyone across the board, be it a remotely located person or a person from high income to a low income strata. Everyone is carrying a device, and that is a very, very strong aspect which we can, as developers, leverage. We can think about large scale deployment, we can think about large scale inclusion, we can think about including the diverse linguistic, the diverse age-related demography, the diverse cultural demography, as well as the users with special needs into our use cases and the list of use cases in order to make applications more accessible and more user-friendly. And built-in features on the mobile phones anyways support diverse needs. So even if you are working for organizations which are developing hardware aspects or which are developing the OS or OS related aspects for your mobile phone, that can also be, you can also think about that aspect, and it is always good to have multimodal interaction enabled in any mobile device. And any good design removes barriers, and accessibility is going to benefit a large chunk of users. So I hope this session can kind of open your mind towards leveraging mobile devices for accessibility and innovation of assistive technologies in your thought process, or if you're already working for organizations which are developing large scale deployed apps, so like the ones from Google's or the Blinkit or Zomato and all of these, which are large scale deployed applications. So maybe you can also kind of share this knowledge with your team as well and inform them about accessibility and how compliance is now regulated by law. And it is important to not just comply but also include a wider chunk of audiences to drive profitability as well, right? So good to talk to you in today's session. I will see you in the next session. Thank you.